So our next type of distribution in Chapter 7, Distribution City, is binomial distribution, right? We've got 4 requirements for our binomial distribution. The first one is that there are only 2 possible outcomes. And then the outcomes are mutually exclusive. So these outcomes are either as a success or a failure. No third option. Second requirement. The number of trials is both fixed and B, known. The third requirement we have is the probability of success must be the same for each trial. And then last, number 4, is that each trial is independent of any other trial. So binomial distribution is a widely occurring discrete probability distribution. It is a subtype of the one that we just discussed. An example of a binomial probability distribution would be a family with 2 young children, both boys. The probability of a third child being a boy is still equal to 0.50. The gender of the third child is independent, or let's say the sex of the third child is independent of the sex of the other 2. I can figure out their gender later. So when we're talking about binomial distributions, we talk about binomial probability experiments. So they have the same rules, and we just have a few different terms, a few different abbreviations that we need to know now. So we have n as the number of trials, right? That's nothing new. Set of observations, now it's the number of trials. And now we have a new variable, pi, which is not 3.1416169 or whatever. It is the probability of success. So how do we actually put this into action? So how do we put this into action? Let's look at an example. So creditcards.com recently reported 28% of purchases at coffee shops were made with a debit card. So this is kind of the background information we're given. And then we're told from 10 randomly selected purchases at Starbucks, at a specific Starbucks on the corner of something and something that we don't care about, we're asked 2 questions. A, what's the probability that no purchases were made with a debit card? And then B, what's the probability that exactly one purchase was made with a debit card? And so in this particular situation, right, we have two mutually exclusive categories, a success of using the debit card or a failure of using the debit card. The random variable is the number of successes for a fixed amount of trials. The probability of success is the same for each trial, right? Somebody going in and paying with a debit card doesn't necessarily influence you paying with your debit card or cash. If you only have cash on you, you're going to pay with cash. If you always use your debit card, you're going to use your debit card, right? There's not a lot of contagion with the notion of like, oh, somebody else used their MasterCard, I'm going to use my MasterCard, right? Not that I've seen, at least. So they are not interdependent. The outcome of somebody deciding whether to use their debit card does not influence your decision whether or not to use a debit card. So we're going to use our binomial probability formula here, our binomial probability formula, which we will put right down below. The binomial probability formula states that the probability of something happening is equal to NC, right? Looking at the combination NCX, multiply this by pi, not 3.14, but the success ratio, right? The success factor, probability of success for each trial, pi to the x power times 1 minus pi to the n minus x power. Yeah, this would have been a nightmare to try to memorize, right? And when are you not going to be able to, like, at least Google what the heck this formula is, you know? Never. So, some definitions, right? We wrote them up there, but let's write them again. C denotes a combination. Combo wombo. N is the number of trials. X is the random variable defining the success, defined as the number of successes. And then pi is the probability of success on each trial. So now we need to identify what the heck each one of these things is, right? So we have pi is equal to 28%. So that's this one. Check. Then we have n, the number of trials, right? So we're asked from 10 randomly selected. So that's our n. And now we still need one more thing, right? Combo, you know, that's just telling us what to do with that. But we need this x, right? We've got the n. C is not actually a variable we need to find in the prompt. Now we have this x, the number of successes. The number of successes isn't actually told to us in the main prompt. It's told to us in the asks, in the subprompts, right? So this one is asking the probability of no purchases being made with a debit card. So this is asking the probability of x is equal to 0. That's what that's saying. This one here is asking for the probability that x is equal to 1. Does that make sense? Okay. So now we are, you know, we're just going to go ahead and apply this formula to each one of these things. So probability of 0 is equal to 10C0 times 0.28 to the 0 times 1 minus 0.28 to the 10 minus 0. That clear how we got from the formula through the prompt to the solution?
The combo means we're going to plug in the combination equation.
Correct. That we learned last chapter. Yep. Or we could also just plug into Excel or Google. Yeah. So when we calculate this 10C1, we end up with 1, or sorry, 10C0. We wind up with 1. And then anything to the 0 power also gives us 1. And then 1 minus 0.28 to the 10th power gives us 0.0374. So 1 times 1 times 0.0374 gives us 0.0374. So there's a 3.74% chance that no purchases of the 10 were made with a debit card. Very low chance, given the fact that 28% of all purchases at a coffee shop are made with a debit card. So these things should also be able to run through our sniff test, our gut check, you know what I mean? We should be able to kind of run them through the prompt and be like, oh, okay, that does make sense. That it would be a small, but like not infinitesimally small, right? If I told you that, 95% of all the purchases at coffee shops are made with a debit card, and you had this same kind of 3% probability come up, that would be like, wait a second, I did something wrong, right? So the fact that it's 30% of all the purchases, and then of these 10, which is not a large sample, the probability of none of them being one of those, near the 28%, makes sense that it's about 3.74%. So the next one is our P of 1. So this is going to be 10C1 to the 0.28 to the 1 to the 1 times 1 minus 0.28 to the 10 minus 1. So this 10C1 gives us 10 times 0.28 squared, or sorry, 0.28 to the 1, which should just give us 0.28. I think this is a typo. Times 0.0520. And so this gives us 0.1456, or 14.56%. So again, this is 10, this is 1 now, that's 1, that's still 0.28, that's still 0.28, that's 10, that's 1. Questions on that? So there are, a bunch of different outcomes that we could figure out for this, right? So since we have 10 randomly selected purchases, we have 10 different probabilities that we can calculate, which we're not going to do. The book does a good job of like going through what those would be and putting them on a chart, which is great. Definitely look through that, but not going to recreate the chart. It doesn't add too much.
Next is how we find more than or less than. Yes?
Cumulative is coming up in a second. Yep.